Good morning, good afternoon, and good evening. I'm Carrie Hoffman, Strategic Advisor for GAVS Technologies. Welcome to the GAVS Technologies webinar, Augmenting Your QA Team with AI. The purpose of today's session is to educate on autonomous testing and artificial intelligence and quality assurance. I'm very excited about today's session as I'm a big believer that AI is meant to augment talent as opposed to replace talent. Today, it's all about augmenting your QA team. Again, I'm Carrie Hoffman and your moderator for today's session. In addition to Strategic Advisor for GAVS, I'm CEO of Hoffman Digital, an ecosystem of companies igniting the human experience at work. This includes Digital Advisor at Focal Point Business Coaching and co-founder and principal at Get Digital Velocity. Prior to this, I have 32 years of experience in 3 corporations, including CIO roles at business units of Johnson Controls and Johnson & Johnson. So it's my pleasure to introduce you to our speakers today. Kevin Surace is chairman and CTO of Appvance.ai. Kevin is a highly lauded entrepreneur and innovator. He's been awarded 93 worldwide patents and was Inc. Magazine Entrepreneur of the Year, CNBC Innovator of the Decade, a Davos World Economic Forum Tech Pioneer, and inducted into the RIT Innovation Hall of Fame. That's amazing. Kevin has held leadership roles with Sirius Energy, Perfect Commerce, CommerceNet, and General Magic, and is credited with pioneering work on AI, virtual assistants, smartphones, Quiet Rock, and the Empire State Building Windows Energy Retrofit. So let's welcome Kevin. It's also my pleasure to introduce Balaji, Chief Customer Success Officer at GAVS Technologies. Balaji has over 28 years of experience in the IT industry across application value management, digital transformation, managed services and infrastructure and applications, BPO and strategic operations, handling P&L, global delivery, operations, and customer success management across multiple verticals. These verticals include healthcare, information services, retail and hospitality, media and publishing, manufacturing and logistics, and consumer goods. Balaji has played various roles across geographies, like the US, continental Europe, and Asia Pacific through his previous stints at Patney Computers, L&T Infotech, Cognizant, Technology Solutions, and Virtusa Software Solution Limited. Balaji's enthusiasm, energy, and customer focus is a rare gift. He plays a key role in bringing new clients into GAVS. Balaji heads the delivery and passionately works on customer success delight. As part of the journey, he has set up multiple QA centers of excellence. He says work is worship for him and enjoys watching cricket, listening to classical music, and visiting temples. All right, as you can see from these bios, this is going to be a lively discussion. So I want to kick it off with a question for Balaji. So Balaji, what are the challenges in the traditional way of running quality assurance that necessitated the role of AI in QA? And can you also talk about the transformation that's happening in QA?
Sure, Kevin. Good morning, good afternoon, and good evening. Thanks, Kerry. The QA aspect, people tend to relate it only to testing, whereas I think QA is broad-based. QA is validation of the business case, validation of the functional requirements, but more importantly, the unsaid validation of non-functional requirements and security. Now, trying to encompass all of this into a life cycle and into one particular team is very difficult, both from talent, skill, time, and more importantly, the ability to carry it out manually. So that has brought in advent of automation. And then automation is used to automate what we know. We don't know what not to automate or what to automate what we don't know. So business analysts, test engineers, architects always want to figure out what could potentially go wrong when the system is put into production, but that is not made available to them easily. I believe AI can actually augment the test engineer or the QA engineer to identify those unknowns which are not captured, and ability to validate them to ensure that the quality of the product is very high and the end user experience is very high. That's where I think AI plays a huge role. And as QA transforms from being a commodity to an automated service to business outcomes, AI actually enhances the ability to drive business outcomes. And that's why I feel AI is very important in QA in the modern world.
Yeah, and it's about augmenting your QA team, right? Not just it's not about replacing them.
It's a big tool for the QA analyst, Kerry, to be more
Yeah,
effective.
absolutely. Hey, Kevin, can you show us some examples of autonomous testing just so everyone knows what we're talking about?
No, that's impossible. Of course I can. And I can also bring a little laughter, whether it's morning, evening, or afternoon, where you are. Look, you know, to add to Balaji's points here is that the need for this kind of technology is happening because our QA cycles are also being compressed, right? People are being asked, QA teams, dev, who's ever working on it, being asked to do a lot more with a lot less time. So if you want to go from a couple of weeks between builds to a couple of hours between builds, and your management is saying, listen, I want to stop our clients and users from finding our bugs, we need to find 5 times, 10 times more, that is 100x productivity the team must have. And how are you going to get 100x productivity? You're either going to hire 100 more people, which are 100 times more people, or you're going to have to leverage some kind of technology, right, to do something different than you've been able to do before. Autonomous testing has been around for 3 or 4 years now, used on millions and millions of tests. I'm going to show you one simple example. And then later in this webinar, I'll explain a little bit more about how that happened, right? So we're going to keep you on the hook a little bit by showing you and then teaching you a little bit about it. So this is real, and what we're doing is we're going to ask a system to generate scripts for us, okay? And we're going to click generate scripts. And in 1.4 seconds, it was done. I hope you didn't blink because that demo literally is over. But we're going to go open one of those scripts. Now, we generated 183 scripts. A machine did with no recording and no human intervention. The machine did it. Now, it did it by learning your application at an earlier point, which we're going to talk about momentarily. We're just going to open one of these scripts. This particular script is 39 steps. It's data-driven already, so those data values are mapped to form fields, right? And this is completely written by a machine. Like, there's no human touched this. It would have taken a human a long time to write this. Okay, so in 1.4 seconds, we generated 27 unique scripts that we want to keep because of some settings that we set up. I do want to say this works on mobile and web today, right? Mobile native, both iOS and Android, as well as web. So really powerful concept. And when you look at the difference, that I know this looks like a marketing term, it happens to measure out around 100,000 times faster than writing your own scripts. Now, people would say, does that replace me? It actually doesn't replace you at all, because the scripts that these write are different than the specific use cases that you're going to need for your business analyst. So these augment those use cases that you might otherwise have, and I'm going to get into later why that's actually important.
So Kevin, you know, my next question was related to what you just said. How can AI augment your QA team? So if they're not writing the scripts like the ones that were generated, what are they doing?
You know what's funny is if you think of the real goal of QA, it's to find the maximum number of bugs in the least amount of time, right? Before anyone else finds them, right? Your goal is to find them all before the user finds any. That's your goal. And somehow over 20 years, maybe a little more, 30 years, since probably Mercury and Rational, we decided the role of the QA team was actually, at least an automated QA team, was to write scripts. That's not actually the role of QA. The role of QA is to find bugs. That's your role. And decide which ones are important and which ones need to be worked on in this sprint, right? That's what we're supposed to do. And I think that's a really fascinating thing when you step back and rethink what you're trying to accomplish here. So if you really step back and say, I'm a professional at finding bugs and everything else is just a tool to help me or a platform to help me or technology to help me. And so AI helping me is a good idea. All right, the reason you've been down in the weeds writing scripts for years is because the tools that the industry gave you were frankly quite poor. I don't know anyone, I've never met anyone who says, I really love writing scripts in Selenium or pick your favorite language. Nobody ever says that. They say, well, that's my job, and this is, I sit here 40 hours a week. In fact, now it's 60 hours a week trying to get them done, and I can't get them all done. So how does it augment your testing? How can you use AI or autonomous testing to augment your testing? Well, first of all, we're going to go find bugs without coding, scripting, or manual testing or recording, and these augment your specific use cases. Now, that's an interesting concept, right? We're going to use a lot of technology, a lot of machine learning in the background to do that. And what I want to do is talk about this process a little bit. I talked earlier about how we have to learn the application the first time. So this is an AI engine. It's kind of like a brain, but it's kind of a dumb brain. It's not really smart yet. And what we need to do is have it go through your application the first time and learn things from you. This is very important. This can take several days, maybe hours, maybe days. But once it's done, you don't have to do it again for each build. It will learn the differences in each build by itself. So we're going to give it a baseline. It's called recursive learning with human-assisted machine learning, right? That's what we're doing here. So we're teaching it a baseline, and after that, it's just going to run every single time. And I'll give you a simple example. You wouldn't want this really smart engine, right, that's at your disposal to log out on every page just because there's a logout link. That serves no purpose, right? You wouldn't want to do that. So you want to teach it to not bother to do that. That's a waste of its time. Ignore that. We don't want to test the logout link on every page. It's just an example. And then what the engine will do is launch 100 little robots, up to 100, and actually start to go through the application with an inherited or already learned component actions library. So it's learned actions within your application. It's learned actions over its lifetime, over the last many, many years. And from that baseline and mapping test data, it's going to map every UI action to every page, to every state, to every set of server requests, right? Eventually getting 100% application coverage, which I'll talk about in a few minutes. And out of that, frankly, comes a report called a functional test report. And that can be used for many things, not just functional tests. You can refine those tests automatically by, and this is optional, but by the system interrogating the API calls in your standard production logs. And it can learn from those over time what users must be doing at the UX level, what requests they're making and when, what flow they're following. And it will write UX scripts, what we call upscaling scripts, using a recursive best match algorithm called predator prey, by the way. This is something you can remember. And it'll write about 5,000 tests every 10 minutes or so. So you could say, I want 10,000 regression tests, true regression tests, and it will write them and it'll apply them to the new build. So any changes in the new build, any new accessors, it automatically handles, changes its own kind of scripts to handle those based on what it just learned. So so you get really powerful results. This is sort of 100% testing of every action and unique page, 100% production user flow coverage. If you want to test that, it's optional. 90%, 98% less effort, but you would have never done any of this. This is coverage you would have never had. There's no maintenance because at every build, even if it's every 2 hours, it regenerates. So that blueprint file regenerates very, very quickly. And this is just an example. If I wanted to find the same bugs, I would have to write all these extra scripts over here on the left, which would take 5,000 hours, which we don't have.
Which would never happen, right?
It would never happen, right? That's the thing. I mean, people look at this and what you realize is you're not finding the bugs because nobody gave you the time or the budget to do so. Not that you didn't have the capability to do it, but the amount of maintenance and the number of scripts you need might take you from 200 critical user flows to 2,000 additional scripts to get to every possible action and state in the application. You don't have the time. Nobody gave you that time. Now you have a machine that will do that for you and augment your other work. You're still going to do that work in blue at the bottom, right? You're still going to provide the 200 critical user flows. You see that on the right there. So there's 200 critical user flows you wrote on the left, and in the new way, you still write 200 critical user flows. So it didn't go away. Then we've given you technology to go faster and reduce maintenance by 80 to 95%. But you're going to find 10 times the bugs about 10 times faster. There's your 100x productivity improvement that we said you would need, because that's what your management's asking for. And you know that, you feel that pressure, but they're not giving you a budget for it. This technology can help augment that. And that's the best use of AI, I think, frankly, across all industries, is to augment our excellent human work and make them more productive.
Yeah, that makes a lot of sense. And I think it's important to remember that that graph on the left where it looked like only 10% was done by a human, we're not eliminating 90% of the human's work. That work wasn't being done before because it wasn't possible to do all that. Right?
That is the critical statement of the hour. The work wasn't being done before. You've never even had time to contemplate what it would take to do that work.
Yeah, so, and that's why we go live and we find bugs after going live.
Of course. Yeah. Actually, our users find bugs. That's the problem.
Yes, exactly. A CIO's nightmare. Okay, so I have a question, Balaji, for you, and then Kevin can weigh in as well. And this question's about the fully autonomous script generation, which, seems like nirvana, although we just saw it happen in, 4 seconds. Is fully autonomous script generation possible, and maybe even a necessity in today's business environment?
Kerry, I think it's a very good question. Reason is, people think that AI cannot do everything, and I agree. But what you have to understand is, when we are doing QA, for example, if I take a new build which has been given to me, I'll do 2 things. One is I will test from the scratch. That will be based on my functional requirements. Or second, I have a regression pack or a test pack which I'll use. But I will test only what I have been told to test. Right? The functional requirements are written, the business analyst writes those requirements, they capture the use cases, they capture the test cases, they create the test data, all of that stuff is done. But it has been seen that at most, you're going to test about 20 to 25% of the code which is written. And that itself is a big number. Because in unit testing, the engineer tests what he has written, not what he's wanting it to perform. The tester tests what he knows needs to be tested, what the engineer has written already. So there could be branches, there could be portions of the code which actually are not even touched either by the engineer who wrote it or by the tester. Now, that is either waste code or a code which will show up in functionality when it's in live. Now, if I have to ensure that the coverage is complete, and if I have to ensure that it tallies with what the engineer has done and what the business analyst from the functionality wants to do, I think there needs to be a mechanism which will bring that knowledge or bring that information to me. And that is where I think autonomous testing plays a big role. I am trying to capture and get a comprehensive understanding of what I don't know, but still I'm expected to know. It not only plays testing, it also plays knowledge about the product. And what I saw during the whole fast run which Kevin just gave, and it was very fast, Kevin, that I'm amazed that it could actually do it that fast.
Yeah.
The one big element which I saw, if people noticed, there were performance statistics which was coming at every point. And what we tend to do, we tend to create functional testing teams, automation testing teams, non-functional testing teams, security testing teams. Now, if I'm having a tool plus a team which can compress all of this together in one shot, and I add it to a 24/7 global delivery model cycle, just imagine the benefit it can get when you have to make like 10, 15 releases a day or much more frequent releases in a week and a month. You're actually eliminating your unknowns, and you're actually making the product and the end user satisfaction quite high. And I think it is very much important to look for those unknowns to be captured much early. People talk of shift left, people talk of various ways of enhancing that risk mitigation process. I think this AI platform, along with the knowledge of what the human business analyst or the engineer brings to the table, actually, though it sounds nirvana, Kerry, it's quite possible and quite needed. And Kevin, yeah, I'm sure you've seen this scenario in many situations where there is a need for the integrated output to be demonstrated between functional, non-functional security. And beyond that, the architectural environment challenges which the application has to go through.
Yeah. I mean, that really leads us right into bringing functional performance and security testing together. It's sort of one of our tenets, and I know it's overall crucial. It is something that we certainly believe in, and I sort of wanted to just note this. This is sort of what we've been hinting around a little bit, but you brought it up. Is on the left is what we typically do today. In fact, we've found now over hundreds or thousands, I suppose, of applications. Typically, the application coverage from your specific test cases that you're reporting 100% test coverage or 90% test coverage is only about 10% application coverage. And let me explain. There's many ways to judge coverage. Of course, the source code coverage, as Balaji mentioned. There is test coverage, and the test coverage is a made-up number. It's a number that the business analyst said these are the critical use cases that I can think of, and I'm not sure they're right, but you have to test those. And then QA tests those and says we've got 100% test coverage of what the person guessed was correct. Well, it's based on a guess, right? They actually don't know, and they're trying to get the time down, so they're just giving you as many as they think you can do, and there's this negotiation, right? But it turns out application coverage is a great way to think about this, because the application has X number of UX actions that can happen in X number or Y number of ways and forms and predecessors and postcessors, so to speak, and it also has X number of pages and X number of states of those pages, right? So if you looked at all of those, you might say, you know, there are a combination of 10,000, right? And maybe, you know, you wrote a couple of hundred scripts, and those 200 scripts get to sort of 1,000 of those things. And so you've got 1,000 out of 10,000, or about 10% application coverage. We found on average it's around 10%, but we've seen things at 6 or 7%. We've seen things at 13, 14%, occasionally 20-something%, but that's very rare. That's a pretty mature application where people have a lot of time to write tests. So we wanted to close that gap, and that's what autonomous testing can do. Autonomous testing can write those other tests that go beyond your specific test cases. You will still have your 100% test coverage, because you will write those in some technology that we have, or another technology, but it's the autonomous test to get all the rest of that. That changes the way the CIO looks at the organization as an organization that is dedicated to find the maximum number of bugs. And sort of, if you think about this, what we've been doing in the old model, and current model, Selenium model, whatever it is we write code, and then we write scripts, and then we maintain scripts, and then we go back and change our code, of course, in our application. We write more scripts, and then we maintain them. And maintenance can be a huge effort. You know what the statistics are in Selenium about, on average, 20% of scripts have to be maintained. This is throughout the industry, yours may be more or less on every build. And of course, it depends on how fast the builds are and what the changes are, and how many accessors are dynamic and things like that. So sort of the new model is a little bit more like this, right? Which is write code, find as many bugs autonomously as we can in conjunction with other scripts we've written, go back and write code, find bugs autonomously. And this loop is very fast. All of a sudden, you've got a 30-minute, a 45-minute, a 1-hour loop, right? That you couldn't have done any other way. That's the power of sort of leveraging this to, again, sort of find your bugs. That's really what we want to do. And we can leverage all of those for different kinds of tests as well.
Awesome. Thanks, Kevin. So Balaji, how do you deal then with the specific use cases which your business analyst told you must be dealt with? And how can AI and machine learning be leveraged for that?
I think that's the fundamental foundation of what QA is all about, isn't it, Kerry?
True.
Business analyst writes what we call as a requirements traceability matrix. And they typically capture the functional requirements and map it to user stories and map it to portions of testing they typically do. Now, it is all driven with the understanding of the business analyst functionality. That's the first start point, right? The functionality is translated. But in the process at every gate, when the architecture design happens, when the pseudocode is written, when the code is written, people tend to follow best practices and bring in elements like complex event processing, tracking and tracing, audit trials. And those normally don't get captured as user stories or functionality because
Oh,
those are
sure.
implicitly understood that those will work. Now, I have seen where situations like the functionality works very brilliantly, but the log files are being dumped so much for
Mm,
every functionality that the disk space got over or it couldn't
right.
write anymore. And then the whole thing froze. They're now going and checking for the functional problem, whereas the problem is elsewhere. Now, that is never captured in a testing scenario. And that is most of the time the problem creator, because statistics shows that majority of the projects are either abandoned or cut short because of non-functional problems, not because of functional problems. Because functional problems are known ones. Non-functions are the main unknown ones. And with the advent of security, the security testing adds complexity. Now, if while I'm doing functional testing, I can get performance statistics of my application at a transaction level, I don't think I'll have to put another cycle of doing non-performance testing or non-functional testing with web load runner and many other tools. I actually have a transaction matrix and the workload available, and I can zero in on what transaction is actually consuming the most utility or the asset in the enterprise and figure out how to optimize it. This actually leads to a concept of QA, not just testing, right? Quality assurance is all about shifting left. Quality assurance is all about finding problems much early in the life cycle because the cost of quality is much higher than actual testing itself in most cases. So that way, a business analyst writes what he knows. The autonomous testing does what he's told as well as finds out whatever is untold and finds out the best way of figuring out how to test it. And that's the beauty of this autonomous testing. And more I'm getting attracted to how the terminologies are evolving in this autonomous testing session.
Yeah, this is fascinating because now I'm imagining all these bugs being found, right? Now you got to take care of all these bugs. So, Kevin, can you elaborate more on how this will be helpful in a DevOps scenario where testing is mandatory for every build? And it seems like this actually becomes DevQA Apps, right?
I love the term DevQA Apps. People have used the term DevSecOps, obviously. Look,
Sure.
the DevOps is all these teams have to work together. The point of DevOps was not to completely eliminate quality assurance. I mean, it might have been the idea for about a minute early on, about 10 years ago, but of course it makes no sense, right? Quality assurance
Right.
must happen. We have to assure that what we built meets the quality requirements, in fact, exceeds the quality requirements, because often our brand is at risk. So, we like to look at this technology in two ways. Remember I said there's specific use cases, and for us, we've got something called Test Designer that is the way that one can create specific use cases and have 80 to 85 to 95% less maintenance on those use cases than Selenium would be. On the right is autonomous test generation. Notice they're both here. One doesn't replace the other. You still do both. You've got your specific use cases. You use autonomous test generation to find, frankly, most of your bugs, but you solve for the business analysts, test coverage number on the left. And as Balaji said a little bit ago, you get from those inputs, right? So if I create a script, a use case, and then I put it together with tens or hundreds of use cases, I can reuse those as functional integration, compatibility, performance, load, app penetration, all the way to synthetic APM. Like, I don't change them at all. The machine will change them for those uses and will always give you a performance characteristics, even at the API level. By the way, even when you run a UX test, you get your API level performance. So you will see what happened at the API, you will see what happened at the UX, whether it's a performance of one user or performance of 3 million concurrent users, the system doesn't care. Mix and match UX with API. I mean, it's the way testing should be. This whole idea of, well, there's the functional team. Over here is the performance team. Oh, there's a security team. In DevOps, you don't have time to go to different teams in order. There's no way to do that. So we want to reuse everything. And we try, in fact, we 100% reuse the same use cases, simply apply them. And by the way, lastly, in this system on both sides, it writes two different kinds of UX scripts in two different languages, basically pure JS and then an English language we call designer script, and also gives you two scripts at the API level you can just use if you want to get rid of the UX and just test to the server, microservices, et cetera, and those are a HAR HTTP archive, and also in JS, which is of course a full language. So this is really cool. So whether the machine wrote them or you wrote them in Test Designer, you get API level tests, you get UX level tests, you can mix and match, you can use them any way you want. I mean, a true unified test kind of platform that allows you to do what you need to do in a very, very compressed cycle.
Awesome. So now my mind's going like towards performance and load testing. So Kevin, how does autonomous testing help with scalability when it comes to performance or load testing?
Well, let me go through a little bit of these use cases and how one can create use cases quickly, and then I'll talk about how those get leveraged. Okay, so we've looked at autonomous testing. I think we really quickly just need to go and look at that thing on the left called Test Designer, right? Because people are going to say, well, for performance and load, I have a very specific use case. Well, again, we want to write those use cases very rapidly. This is not the AIQ platform. This is just Selenium, and everybody knows what this is. And basically here in a simple example, in 20 minutes or so, I've written a 16-step script. It's not data-driven yet. It's not a great script. It's just against an e-commerce application. And here I'm using some ML assistant technology that I'll share with you in a second to do the same thing. So these are the same 16 steps. All I'm doing is, instead of taking 20 minutes, I'm already on step 8. You can see on the left, the script's being written in one browser window on the left. And on the right is my application, literally on my desktop, through a browser that I'm testing, right? So as I'm working in one browser window, it's recording in another, right? And this is totally browser to browser, totally on your desktop, really powerful concept. And it's all at the JS level. So it's actually inside each iframe, looking at what's going on. There's machine learning here that allows us to pick better accessors than humans could pick by themselves. By the way, that was real time, and there's same 16 steps done. The same 16 that was done in Selenium in 20 minutes and 41 seconds is done here in 64 seconds. It's the same script. So if I wanted to use this for functional or I wanted to use it for performance, it doesn't really matter. It is about 20 times faster to write tests in Test Designer than writing them in Selenium. But now we talk about maintenance, right? And maintenance often has to do with dynamic accessors and accessors changing. And we support some 24 different kinds of accessors, including image recognition. You can prioritize those. Then you can optimize your script where the system itself will go and rewrite. We're going to show you that here, this script right in front of you. By rerunning the script 5 times right on your desktop, finding better accessors that are more stable and rewriting the script right in front of you. Absolutely powerful technology. You don't have to do anything. This mimics what you used to do manually for highly dynamic applications. You don't even have to do that anymore. Then when a test is running, again, whether it's for performance and load or whether it is for functional, we will keep the test running by using something called accessor fallback. So the system automatically continues to build out an accessor library for each element, and it'll fall back step by step by step to keep your test running. So if the first accessor doesn't work, it'll find another one and find another one and find another one for you. Your test keeps running. Absolutely powerful. Everyone wishes they had this for the last 10 years. Actually, we've had this for about the last 5 years, so you can have it. And then it'll lastly rewrite the scripts using that object repository that it built up and say, it's time to rewrite this script. It's broken in so many ways. And it will do most of that automatically, if not 100% automatically, and then allows you to accept the change. So again, we're trying to take all of that maintenance that you used to have to do and simply take it away from you. You know, you asked about the sort of DevQA Apps point, and this sort of demonstrates that. Even though I've been showing you buttons and clicking and starting things and all that, everything really gets kicked off from the outside. And this is a great example of really supporting DevQA Apps in the right way, which is I'm going to kick off a set of tests with a set of inputs against the dev server. It's going to come back with pass-fail flags and other criteria and dashboard results. And we're going to do it again against staging, do it again against pre-prod, do it again against prod, fully automated. That is true automated continuous deployment with QA at the center of that. And every time this stuff comes back, the QA team is analyzing what came back and signing off on whether it should continue on and go to the next stage. You can also automate that. So I think that gives a pretty good overview of sort of DevQA Apps, how you can create these scripts and how those scripts can be utilized for functional performance. We didn't talk too much about security, but there's the security module as well. So for app penetration, you can leverage these scripts. And the reason you want to leverage a script is so that it can find other areas in the application that it would not normally be able to get to by spidering, right? So if you don't fill in these forms, you don't get to the next page. So with a script, all those forms can be filled in all the way to the end. It can get to every single page and actually run security on every single page, in every state actually in your application, without you rewriting a script, just using the ones that you've already written, perhaps for functional or performance.
So this is fantastic. It's music to my ears to have QA involved all along the way and inserted right in DevOps. I'm going to ask just a couple more questions, and then we're going to turn to the audience for questions. So everyone, feel free to start typing your questions into the chat box, and we'll get to as many of them as we can. So Balaji, I have a question for you. We've seen how blueprinting each build is playing a major role going forward in successful QA. Why is this critical, and how does it help in the shift left in QA that you talked about earlier?
This is actually a new concept in itself, Kerry. People talk of blueprinting in functional design, in technical design, in deployments, but people never speak of blueprint in QA, because they think that we know everything what needs to be tested. But the sad part is, most of the times when the applications are written, either for regulatory or compliance requirements, or for performance statistics and diagnostics, or for future use, like an audit trial, right, from an archive, people dump lots of log files, production logs, audit trials, sometimes even archives automatically, right? And they send events to various complex event processing systems when they are talking about trading systems, stock brokerage systems. They do a lot of complex event processing. And then they send traps to various other systems to capture and act on. Now, those are all actually valid areas which demonstrate parts of the code which are critically used by the normal users. Now, if I'm able to infer functionality from that or user behavior from that, and then map it to what I should be testing, it would be cool, isn't it, Kerry?
Yeah, it's very cool.
So many of the disparate users who could actually be testing a particular functionality for various reasons. And I was talking to one of the large healthcare customers recently, where they said that I know where my source starts, but I'm unable to figure out where my destination is with regards to my CI/CD pipelines. In a similar manner, if I'm able to find out how to get to the destination from various other log files or diagnostic information, normally applications and business processes throughout, and from there infer back and augment whatever I'm testing to say, this is all what others are using, which I have not tested, but that's how they use, that's the behavior or pattern in which the user is using, and use that. That's the blueprinting I'm referring to. I'm actually referring to the blueprinting, capturing user behavior once it is being used, and then feed it back into how that blueprint can be used to augment whatever test cases I've written or test scripts I've written. In my practical usage of what the platform Kevin showed me, that is something which attracted to me. If I can bring the problem of what the user can do earlier on in the life cycle, my defect removal efficiency increases, my defect iteration testing changes, my speed of rollout changes quite a bit. So capturing what a behavior of the user is, or the scenarios which the user does from the application, not from the end user alone, from the application itself, and using it reversely to test and validate, I think is a great way to figure out how you can actually impact the quality of the product itself.
Yeah, so this is awesome, Balaji, because what you're talking about is creating like this cycle where you can take that user behavior after it's gone live and cycle it back into the blueprinting of QA.
That's right.
Really cool. So I have one more question, and then we're going to open it up to the audience. So again, you guys can type in chat if you have any questions. So Balaji, we haven't touched on security too much. So how will AI be used to overcome issues with non-functionality and security-related defects?
Kerry, I think I go back to my earlier point, right? Majority of the time, what is cut from your life cycle is non-functional testing and security testing. Because our thought process is that it works for non-functionality automatically. It works for security. I know how to write a code which is secured, right? But what we do not know is in the process, we are actually using components and not writing the code like the way we were doing earlier, which automatically introduces vulnerabilities. It could be because of patch problems. It could be because of version upgrades. It could be because of some legacy code which has not been tested properly. All of those introduce vulnerabilities. Now, most of the times people have this mathematical model of saying 30% of your time is to be spent in QA and testing. But within that, they hardly spend 5% in performance testing and security testing. Who finds them? The end user, not the actual developer. And what happens is you are functionally very good, but when you put into production, it freezes. It doesn't scale. And I think it is critical for us to understand that when a particular performance testing needs to be done, it has to be functionally right. So there's also a theory which says you test for performance only after it's functionally right. But what it would be cool, isn't it? I can test for performance as I'm testing for functionality. So I'm actually, in a way, shifting left my ability to find problems in my life cycle. I think that is very important in performance and security. You're not deferring it to later, because if you find problems in performance and security, you probably have to go back to the drawing board to do the re-architecting once again. That may not be true with functional testing. So your cost of quality and cost of rework is going to be significantly high. What I find good about this AI, because it looks at the 360 dimension of a test scenario, it is able to capture performance statistics and diagnostic information. And I come from this AI ops world where we are actually using a lot of tools in the infrastructure and operation space. Majority of the times, these log files and others are seldom used. What if I can put it to best use, not only finding problems as they happen, but before it can happen from a functionality standpoint? I think that would be the best usage of some of the disk spaces and the storages which we are trying to use for these log files. And that's what I was referring to, doing it simultaneously and augmenting your functional capability at one shot.
Awesome. Kevin, do you have any comments on let's say, the security aspect of testing?
Yeah, look, I think that it's important to recognize, as Balaji said, that performance and security should be part of your DevOps cycle at every single build. How is my application performing for an individual user? How's it performing at load? Have I introduced a security issue, an app penetration issue in over the last build? And I have seen this over and over again where people say, well, we're not going to do security because we have Security Center of Excellence. I said, how often are they going to test your application? Once every 6 months. I said, well, how often do you do a build? 4 times a day. So sure enough, in 6 months, they find a whole bunch of issues that happened 76 builds ago that you could have squashed immediately. You know, when you're doing a rapid app penetration test, you are not trying to be at the depth and breadth that an outside firm would take 3 weeks to do on your application. You're trying to know in an hour if there are any things that bubble up right away that could be a security issue to your company. That's what you're trying to find out. That's part of DevOps, right? We can't do everything, but we're going to do as much as we can in an hour or 2 or 3, right? And so I think it's incredibly powerful, and I don't know anyone who wouldn't want to do that. But the fascinating thing is a lot of our teams just aren't set up that way. Like the functional team doesn't even know the security team. I don't know, they're in some other country, they're in some other building, right? They're in something, I don't know, they don't know. And they don't even know the performance team is. And as Balaji said, is the performance team often, you know, they don't get 5%, sometimes 1% of the overall time of the application development cycle, right? And that doesn't make any sense, because if the application is released and doesn't perform well, whether it's for 1 user or 1 million users, right? So when I talk about performance, I mean it broadly. Well, then you have nothing. Even if it functions properly, but it's slow as a snail, nobody buys anything, nobody executes what it is. I see so many applications, I'll tell you, it's awful today, that they say, well, the functionality is great. I said, well, you know, when our system is testing it, some of these pages take 16 seconds to load. Oh yeah, that's how it works. Right? 16 seconds. No, Google can search the web and return a result, right, from its very large database in
10
under
million results.
Okay, Amazon can return any product request in under about 300 or 400 milliseconds. And I don't know what you're doing in 16 seconds, but is it building a nuclear weapon? I mean, I don't know, right? It must be immense, right? If it takes 16 seconds. So
no one's willing to wait 16 seconds anymore.
Well, they think it's okay because we're the functional team. We're not responsible for that. Well, where's the performance team? I don't know. There's one guy's over there. Maybe they laid him off. I don't know. Right? Oh, and you can't help these people, right? And I know some of you are laughing along with me here, and we mean no disrespect, but this is what happens in organizations, and the CIOs or the VPs forget that testing and quality assurance is about functionality. It is about security. It's about performance. It's about performance with performance at load. And it's finally doing it all the way up the server cycle, right? Each different environment, so that when we get to production, it is working properly. You haven't overloaded the log file system, ran out of disk space, and the whole thing crashes, right? And by the way, it's quite easy to test because we can load the thing with 500,000 users for 15 minutes and then look at what happened to the disk space and extrapolate that. So we have all the tools to do this. People just aren't doing it. We've tried to put it together and make it certainly a lot easier. I know there's some questions that have come in, so I want to stop and make sure we get to a couple of questions anyway before we time out here.
Yeah, let's definitely do that. And just a reminder, if you do have a question, type it in chat. We're monitoring the chat, and we're going to start going through those questions now. So the first question that I have is, can you automate signature and photo captures?
So there are methods to do that, and that's a loaded question, of course, because the easiest way to do that is preset them and spoof the system and say, here is the signature, and you just load it, right? The same true with the photo capture. I mean, we use often in some of these test requirements, we spoof the photo, right? Because if you're not spoofing them, then you actually need a camera or a capture device. And when you actually need a camera, we've got a customer right now that actually brings up the camera to do some facial recognition. So yes, we know how to do that. There's not an actual face in front of it. We're kind of spoofing the face. I won't tell you how we do it. But anyway, yes, the answer is yes, but it depends on what you want to do. What you don't want to do is be there and have a human that has to actually write the signature. So we're either going to write the signature with code, which by the way, we know how to do, or we're going to spoof the signature, right? So those are your choices. And we could support either one. There's very little that can't be automated, but I would say sometimes people, like sometimes we've got people who said, well, we want to know if this song is playing. Well, you're going to put someone next to the box that hears the song playing, or of course we can automate that, send it to Shazam, get data back from the Shazam API that says that's the right song. So there are often solutions even when you think there are none.
Yeah, I instantly thought of Shazam as well.
That is the trick. I'm giving away all the tricks today.
So another question, and let's see if I get this right. Also, are you able to test TLS to see what TLS the app is using?
I presume this app is using, right, Kerry?
What?
Say that again.
Are you able to test this to see TLS to see what this app is using, maybe?
Right, I see what you're saying. That's a good question because the answer is perhaps. I mean, people haven't done that before, but I wouldn't say never. I'd have to think about the best way to accomplish that, especially with autonomous testing. Which is the best way to do that in a way that gives us something useful back? But great question.
Yeah, great question. Okay, another question that we have, does the platform help in fast-tracking regression testing?
Well, yeah, yes. So, but your thinking of regression testing is, here's my regression test suite that I wrote, therefore that's what we're going to run. But real regression would not be that. Real regression would be, here's what my users are doing in production. Right. Can I map those to the current build and run those? That's actual regression, right? Because what you want to do is say that when I put this new build in production, that the flows that the users are doing will still run at some statistical level, right? And so because we can map the log files, and we're the only people who've ever done that, and these are standard W3C log files, We have a number of we have 8 patents in this stuff, by the way. What it allows us to do is write real regression tests, and say, all right, when you deploy this into production and people want to follow similar user flows against this new build, this is what that's going to look like, and this is what the bell curve looks like of usage. And so we have all of that. That's really, really super fascinating, I think, and it's very fast. I mean, 5,000 regression tests are written every 10 minutes. So I don't think a human can beat that.
I don't think so either. That is really fascinating. Okay, another question. How is Appvance different to IAST, Interactive App Security Testing?
Sure. The only security module that we support here is DAST, D-A-S-T, so it's Dynamic Application Security Testing, and that's it. So the only thing we're doing is app penetration with a fully functional application that can be run in a very short period of time by running 100 threads in parallel or so. That's the only security that we do. There's all kinds of other security, right? There's source code security that you should be doing all the time. There are great products for that. The idea here was just to re-leverage or leverage the scripts that you've already written in Appvance, right? So we want to take those scripts and be able to use them to get through the application to do a holistic DAST test. So look at it that way. It's compartmentalized right there. There are lots of other security things you can do, you should do. This was a way to reuse those scripts because DAST is done at the functional level. So so that's the one that makes sense to do.
Kevin, does it also do scanning? Does it also scan your code to find vulnerabilities rather than just do testing?
No, it doesn't do source code scanning because we're not on, if you think about it, this system is never on the source code side. It's at the API side, but we never see your source code. I mean, arguably we see the source code in the browser, right? Because it doesn't compile, but everything else, we don't see the source code. So we're always post-integration.
And I think that's the answer for your next question anyway. So
right, that's right.
Yeah, so okay, we're gonna cover questions for about 3 or 4 more minutes, and then I'm gonna ask both Kevin and Balaji for their last comments to close out the webinar. So the next question was kind of related. Can this work with no-code app development tools?
Yeah, I mean, we don't care how the app is developed, whether it's done with no code, whether it's done with AI, we don't care if it's .NET, if it's Java, if it doesn't actually matter because you've compiled it and all we're seeing is the UX. Now we see the UX in the API actually, so we see the full stack up front, but we never see your code. So we really don't care how you develop that code. Remember, we're looking for functional test onward, functional performance load, DST security, you know, those kinds of things. So we're really at that end. Before this technology, you would have already done your unit testing, or your developers should have already done their unit testing. They should have already done source code scans, etc., and they'll use the right tools for that. So this industry tends to be split at that point, right? There's sort of tools over here to the left that work on source code and work with the developer for unit testing, and then then you've integrated your application, and then there's a whole set of automation that takes place to the right, more on that side.
Okay, awesome. So Balaji, I'm going to have you answer the next one. Is an autonomous testing platform like a silver bullet for your QA team, or does it need to work with other tools? Like, does it complement and augment the existing testing process?
I think the slight change in the way I'll represent it, Kerry, as a response would be, it is not a process, it is actually intelligence. So it's not the process which matters here. You could have any process. What we are trying to do is we are trying to augment our ability to identify and understand what potentially could go wrong. So it can definitely be a complement and with other tools. That's not a problem at all. However, I think it should be viewed from not a template or a process, but the intelligence augmented to the test engineer or your test cases to be able to elaborate on the coverage of functionality and so on. That's how I would view it.
Great, thanks, Balaji. Okay, let's see if there's any more questions from the audience. Okay, I do have another question. Okay, so with AI, does this mean that there need not be any test cases or scripts written? Do we need to have a minimal set of scripts written?
Well, let me give you my recommendation. My recommendation is that your business analyst has said, I want 20, 50, 100, 200 use cases covered, period. Just do those. And the reason is more psychological than it is technical, because theoretically the autonomous engine will write those same scripts if you trained it properly, if you set it up properly, and it'll validate even far more than those scripts would validate. But it's critical to tell your business analyst that you've got 100% of their test coverage, and the best way to do that is write those scripts here in Test Designer with much lower maintenance. And then you can honestly say that. Otherwise, you spend all your time trying to convince them that somehow the autonomous engine found all the same things. Not worth your time. And you're not going to win that argument today, right? Because they go, AI, I don't understand it. I don't know if it's real. I don't understand these 19 algorithms that are used in this product. I just write my scripts. So just write.
I think they're like from a business perspective too. I think that there could be functionality that's expected that just didn't get written, right? Like somebody's missed it.
Sure. That's exactly right. That's exactly right. And the engine might not know, depending on how you set up what's called validations, which we didn't talk about today. But that's our recommendation. Now, we do have some people, especially in mobile, that have said mobile scripting is so hard to write and maintain, native mobile, that we are going to 100% rely on autonomous testing there. And they've been successful doing that. Now, they've spent a lot of time setting up correctly, and they spend a lot of their time setting up validations to make sure that it's working correctly. But they spent no time writing scripts. They let the system write the scripts. By the way, one thing I didn't say is anything that the autonomous engine writes, we give you all those scripts. If it writes 2,000, you can actually take them, put them back in the IDE, change them. Like the machine wrote the script for you. You can actually use the script and use it as a regular script every day if you wanted to, right? So nice. This is all back and forth. It's, you know, sort of full IDE mode, if you will.
Very cool. Okay, so I think we come to the point where we're going to take final words from both Kevin and Balaji before we close out. So Kevin, any final words that you want to?
No, I think I've said enough, but I will say this. Look, this is a fascinating field, and I mean, if you're not participating, I don't understand why. If we sat here and said 20 years from now, software will find most of the bugs in our software with little human input, probably nobody's going to disagree with me, right? Well, we have that today. That technology is available today. It augments your team, and it makes your, you know, team of, I'm going to make it up, your team of 20 sort of like a team of 200 or 2,000 or something like that, right? That's the power. So you're going to still use that team of 20. They're still going to have plenty more work to do, right? They're going to find more bugs, etc. But now they're really leveraging technology. They're becoming a little bit of the robot overlords, as we say, rather than I have to write more scripts, right? So I think it's a fascinating time, and a fascinating time to participate in AI in our field.
Awesome. Thanks, Kevin. How about you, Balaji?
I think coming from operations and execution, Kerry, one thing which baffles me is that we tend to bring functionalities and components which we don't have enough knowledge about. Most of the time, somebody else has built it, I just use it. So I do not know how, when they come together, actually can meet some of my requirements. So it is best to have AI augment that limited knowledge you may have to provide you that additional knowledge which can actually make the platform or the product much better. I think there is a significant play for AI in anything which is repetitive and anything which can learn and become better. And QA is a nice area where it is. One good fascination, because being involved in lots and lots of QA initiatives for so many years, Kerry, I always feel that the QA is going to die away, but it reinvents itself. And I think, Kevin, and we thought today how actually technology can reinvent QA and make it worthwhile, to make it central focus of what a user experience should be, what time to market should be, and what cost should be, and more importantly, what quality should be. I think it's time people start giving serious thought to AI augmenting QA and take it forward from there.
Awesome. Thanks, Balaji. Yeah, and you know, from my perspective as a former CIO, it's all about finding as many bugs as possible before you go live. So an augmented QA team with AI becomes a hero. I want to thank Kevin and Balaji for a very dynamic and awesome webinar today. And thank you all for attending the GAVS Technologies webinar, Augmenting Your QA Team with AI. Thanks and have a great day and a great evening.
Thank you all.